Have you ever wondered what the deadliest planets in our galaxy are? The cosmos is a vast, diverse landscape teeming with celestial bodies, each possessing unique characteristics that make them fascinating, yet often inhospitable to life as we know it. Among these, 5 planets stand out due to their extreme conditions: Venus with its suffocating heat and pressure, Jupiter, known for its violent storms and lethal radiation belts, Gliese 436b, a hot Neptune with its burning ice, HD 189733b, a world where glass rains from the sky with winds racing at breakneck speeds, and finally PSRB 162026b, also known as Methuselah, an ancient world that has survived the harsh radiation of a binary star system for billions of years. These planets are a testament to the extremities of the universe and the resilience of celestial bodies. Let's journey through the cosmos and explore the extreme attributes of these 5 deadly planets. First stop on our deadly journey is Venus, our solar system's literal hot mess. Aptly named after the Roman goddess of beauty, Venus hides a deadly secret beneath its mesmerizing golden clouds. It is the epitome of a greenhouse nightmare, a world where carbon dioxide reigns supreme. This thick, unyielding atmosphere traps heat from the sun, creating a searing surface hotter than the hottest oven. Picture this: you're standing on Venus, except you're not standing because the atmospheric pressure here is over 90 times greater than on Earth. It's like being almost a kilometer underwater, a crushing weight that would flatten you in an instant. The air around you isn't air at all, but a dense soup of carbon dioxide with just a hint of nitrogen. And it's so hot. How hot, you ask? Hot enough to melt lead. Yes, you heard that right. The surface temperature on Venus can reach a staggering 467 degrees Celsius. That's hotter than the surface of Mercury, even though Venus is nearly twice as far from the sun. But it's not just the heat that's extreme. Venus's environment is so hostile, even our best spacecraft don't last long. The Soviet Venera probes, the only spacecraft to ever land on Venus, survived mere minutes to hours before succumbing to the intense heat and pressure. The winds on Venus are no joke either. In the upper atmosphere, they can reach speeds of up to 350 kilometers per hour, whipping around the planet in a phenomenon known as superrotation. Despite its close proximity and similar size to our home planet, Venus is anything but Earth's twin. It's a cautionary tale of what can happen when greenhouse gases run amok, creating a hellish world of extreme temperatures and crushing pressures. Venus, a world where lead melts like ice cream on a hot summer day. Next, we voyage to the largest planet in our solar system, Jupiter. Jupiter, the colossal gas giant, holds a reputation for its tempestuous nature. Its atmosphere is a maelstrom of violent storms, swirling with winds that soar up to 340 meters per second. The most infamous of these turbulent tempests is the Great Red Spot, a colossal cyclone that's been raging for at least 300 years. This storm is so enormous that it could swallow Earth whole. Not once, not twice, but thrice over. Imagine, if you will, a hurricane that has lasted centuries, with winds whipping around at speeds that would leave our terrestrial hurricanes looking like a gentle breeze. Yet the storms are not the only perilous aspect of Jupiter. The planet boasts an incredibly strong magnetic field, a protective shield against the solar wind. However, this magnetic field also generates lethal radiation belts. These belts, named the Van Allen belts, hold so much radiation that even robotic spacecraft need to be carefully shielded and guided to survive Jupiter's hostile environment. The radiation belts are a result of Jupiter's intense magnetic field trapping charged particles from the Sun. These particles, primarily electrons and protons, move at nearly the speed of light and can easily damage or destroy electronic equipment. For any human daring enough to venture close, the radiation would be lethal in a matter of minutes. It's a world where immense storms that dwarf our entire planet rage perpetually. A world where the very magnetic field that protects it also creates a swathe of deadly radiation. Jupiter, in its grandeur and might, serves as a stark reminder of the raw, untamed power that resides within our own solar system. Awe-inspiring yet terrifying, Jupiter is a stormy giant that encapsulates the deadly beauty of the cosmos. So as we journey through the galaxy, exploring the deadliest planets known to us, we find each world holds its own unique and dangerous charm. Jupiter, a world of storms so massive, they dwarf our entire planet. Leaving our solar system, we encounter the exoplanet Gliese, 436b, Lying about 33 light-years away, Gliese 436b is an enigma that challenges our understanding of the universe. This world, categorized as a hot Neptune, is a fascinating place, with temperatures on its surface reaching a scorching 439 degrees Celsius. That's hot enough to turn lead into a molten puddle. What's interesting is that this blistering heat is found despite Gliese 436b being in close proximity to a rather dim star. In the realm of the cosmos, this exoplanet is practically hugging its parent star, orbiting it every 2.64 Earth days. Yet the star it orbits is not a fiery ball of intense heat, but a relatively cool red dwarf. But the real paradox of Gliese 436b is not its high temperature or its closeness to its dim star. No, it's something even more mind-boggling. Picture this. Burning ice. Yes, you heard that right. This exoplanet likely hosts what's known as hot ice or Ice X. This isn't your run-of-the-mill ice cube from the freezer. This is a form of water that behaves like a metal, remaining solid under extreme heat and pressure. The high gravitational pressure on Gliese 436b compresses its atmosphere, which is rich in water vapor, into a solid form. Even though the temperature exceeds the boiling point of water, this ice doesn't melt. Instead, it catches fire, creating a surreal spectacle of burning ice. So in this topsy-turvy world, water doesn't follow the rules we're used to. It doesn't flow. It doesn't quench fire. It burns. An endless sea of flames fueled by the very substance we associate with extinguishing fire. Such is the nature of Gliese 436b, a place where the impossible becomes possible, where the known laws of physics take on a new interpretation. It's a testament to the universe's capacity for wonder and mystery, a reminder that there's still so much more to discover. Gliese 436b, a paradoxical world where ice burns. Our next stop is another exoplanet, HD 189733b. This celestial body is unlike anything we've encountered before. Imagine a world where it rains glass sideward. Yes, you heard that right. This planet experiences a phenomenon known as glass rain, where silicate particles condense in its atmosphere to form shards of glass that come plummeting down. But it's not just the glass precipitation that makes this planet so unique and terrifying. The winds on HD 189733b are so intense they reach speeds of over 7,000 kilometers per hour. That's fast enough to whisk you from London to Sydney in less than 20 minutes. This makes the sideways falling glass shards even more deadly as they are carried at these breakneck speeds. And if the slicing glass rain and terrifying wind speeds weren't enough, the temperature on HD 189733b might just tip the scales. This exoplanet is an absolute furnace, with temperatures soaring to over 930 degrees Celsius. That's hot enough to melt most metals. This is a world where survival as we know it is impossible. A world that redefines our understanding of extreme weather conditions, a world that, despite its deadly nature, continues to fascinate us, pushing us to explore and understand the farthest reaches of our universe. HD 189733b, a world where the rain would slice you to ribbons. Finally, we arrive at PSRB 1600-2026b, one of the oldest known planets. This ancient world, often referred to as Methuselah, has been around for an astounding 12.7 billion years. To put that into perspective, Methuselah is nearly 3 times the age of our own Earth. Uniquely, Methuselah orbits a binary star system. That's right, it has 2 stars for its suns. This cosmic dance plays out in the constellation of Scorpius, where the planet endures the gravitational pull of its 2 stellar companions. Now, you might be wondering what kind of conditions could exist on such an ancient planet. Well, the truth is, they're likely quite harsh. The immense age of Methuselah, coupled with the radiation from its binary stars, suggests an environment that is incredibly hostile. Despite this, Methuselah has survived unyielding through billions of years. It has seen stars born and die, witnessed galaxies collide, and watched the cosmos unfold. It's a testament to the endurance of celestial bodies and the fascinating diversity of our universe. And so, we conclude our journey with the oldest of them all, a planet that has stood the test of time, a testament to resilience and survival. PSRB 1600-2026b, a world that has witnessed the universe grow up around it.